All right, so implicit differentiation, okay? So first, before we talk about implicit, we need to talk about explicit. So an explicit function, a variable y, is explicitly written as a function of x. This is what we're used to. We're used to seeing something like y equals f of x, where it's some function of x. So maybe like y equals 1 divided by x. Basically, with an explicit function, I'm able to solve for y pretty easily, okay? So what is an implicit function? This is used whenever it's really hard, hard to solve for y. So an example of something that would be hard to solve for y, so you have this equation here. How do you get y by itself in this situation here? You got a tangent of y and a y squared. That's going to complicate things. How do you get something that would be explicitly a function of x? You have y equals something, right? We don't really have a clue how to solve that, okay? So since we take the derivative with respect to x, then we must treat y like a chain rule, okay? So we treat it like something we don't know what it is, right? Like if we took the derivative of sine of something, right? We took that derivative of sine of something with respect to x. I say it's equal to the cosine of something times the derivative of that something. I treat it like a chain rule. So I'm going to do the exact same thing with this part here. I'm going to, instead of being a something, that something, maybe it's a y here. Okay, so I'm taking the derivative with respect to x of that sine of y. Okay, so I treat y like a chain rule. So the derivative with respect to x of some function of y, all right, it's not a function of x, it's implicit here. So that could be some function of like x and y, like two variables, like this would be going on here. You'd have x's and y's, right? So to take this derivative, I take the derivative of the outside function of y and then multiply it by the derivative of the inside. Well, what is the inside? The inside is y, so the derivative of y with respect to x is dy dx. Okay, so this is how we use the chain rule to take the derivative implicitly. So let's do a problem where we do the derivative the old way and we just take the derivative explicitly. And so when we do that, what do? I take the derivative of the left, I take the derivative of the right. Derivative with respect to x of y is equal to dy dx. The derivative with respect to x of 2x squared, well, what happens? The 2 comes out front. I get 2 times 2 is 4, and then x, subtract 1. I have a 1 exponent there. Pretty easy, right? Now, let's do one where we use implicit differentiation. So implicit, now instead of y is a function of x, so y equals something, now we have, say, y squared equals this. Now I know you're thinking, okay, but what if I just did plus or minus square root of 3x? Yeah, you could do that, but then you've got two cases. You've got the positive square root and the negative square root, which is not as slick as having one equation like it is here, and we use implicit. So this is where it's valuable. So I want to walk you through step by step how to do implicit. Step number 1, I want to differentiate both sides with respect to x. Step number 2, I want to get all the terms with dy dx on the left and move everything else to the right. Okay. Step 3, I want to factor out dy dx on the left. Okay. And then step number 4, the last step, solve for dy dx. Okay. So that's the last step, solve for dy dx. So step 1, take the derivative with respect to x on both sides. So I'm going to take the derivative with respect to x on both sides here. So the derivative of y squared with respect to x and derivative of 3x with respect to x. Now, once I take the derivative, I need to use a chain rule. Derivative of y squared. Remember, treat y as something. How do I take the derivative of something squared? That's 2 times something raised to the 1 times the derivative of the something, okay? So what do I get? I get y and then bring the 2 out front times something. Okay, what's the derivative of the something? The derivative of y with respect to x is dy dx. Okay, over here on the right side, it's same old, because look, I'm taking the derivative with respect to x there, and I have an x here. So I treat it just like that. I take the derivative, I get 3. Now, what does step 2 say? Get all terms dy dx on the left and move everything else to the right. All the dy dx terms are on the left. Step 2 covered. Step 3, factor out dy dx on the left. Well, it's already factored out. Okay, step 3 covered. Now the last step, solve for dy dx. How do I solve for dy dx? I divide both sides by 2y. And if I divide both sides by 2y, I get 3 over 2y there. Okay? So I hope this step by step helps you out. This one here, we could skip step 2 and step 3. Typically, you've got to use step 2 and step 3 when you start talking about more complicated implicit derivatives, and we'll save that for the next video. But the big overall reaching idea is I use implicit differentiation whenever I can't easily solve for y. And so a situation like this here, it's not easy to just solve for y here, and even other situations like this where it's basically impossible. So literally all you need to do is treat y like a chain rule, and when you treat it like a chain rule, then you get to this situation where you have a dy dx, and you get dy dx by itself, and you've got your answer.